hang up and try again.
Welcome to Nizar Kiwan with YouTube channel Math Everywhere. I am an IB high school teacher in San Francisco. So here is the part 4 or 5, I don't remember. Rule number 25. What is the derivative of e to the power x? The only function in the world that has the derivative same as the original function is e to the power x. So the derivative is e to the power x, the same thing. Rule number 26. Fx equals e to the power ax plus b. Since the power or the exponent is a linear function, so I will take the derivative of it, which is a, so I will drop a down. So the derivative would be a times e to the power ax plus b. Example, what is the derivative of e to the power negative x over 2 plus 3? The derivative of this linear function is negative 1/2, drop a down, times the function itself. Rule number 27. What is the derivative of e to the power jx, another function which I call cocktail? The same technique in trigonometry and exponents, same thing here. Just take the derivative of this and drop it down. J prime x times the question itself, e to the power jx. Example, what is the derivative of e to the power cosine 2x minus 1? So here the exponent is a trigonometric function. The derivative would be, we take the derivative of the power and we drop it down. Cosine starts with c, so the derivative is negative. Since the angle here has a linear coefficient 2, so we multiply by it outside, and the cosine will be sine, and the angle is written as it is, times the original question as it is, e to the power cosine 2x minus 1. Or exponential functions. What if I have, instead of e to the power something, I have any other number, a to the power x? The rule says it stays as it is, but don't forget to multiply by len the base. But remember here, a must be greater than 0, must be positive, because for len a, inside len must be always positive, otherwise it's gonna give you error. So this is the condition here. Rule number 28. What if I have a to the power ax plus b or bx plus c? You know what, Hamar? Example for that. What if I have pi to the power x? So the derivative would be, pi is a number, 3.14. So len pi times pi to the power x. That's all. Another example, what if I have 7 to the power x? So the derivative would be len 7 times 7 to the power x. That's all. Rule number 28. What if a has not only power x, what if it has a linear function, bx plus c? Same thing. We write the function as it is, but since this is a linear function, the derivative of the angle is b, the derivative of the exponent is b, so we multiply it by it now down. And since this number is not e, we have to multiply by len a. Example, 3 to the power 7x minus 1. So a is a 3, b is 7, c is negative 1. The rule says, don't forget to multiply by len 3 first. Now, consider as exponential function e to the power. So since the power is a linear function, the derivative of it is 7 times the same function, 3 to the power x, 7x minus 1. You cannot multiply 7 by 3 here because you have len 3. Another example, what if you have 2 to the power negative 3x minus 1? So the rule says, don't forget to multiply by len 2 down. And now, since the power is linear, you multiply by a, which is negative 3. Then the same function, 2 to the power negative 3x minus 1. Rule number 29. What if I have a to the power cocktail, which is jx? The rule said, don't forget to multiply by len a down. And now consider as e to the power gx. We have taken that before. The derivative of the power, put it down, times the question itself. Example, what if you have 3 to the power cosine minus 2x minus 1? So this is exponential function, but the base is not e. So we need to multiply by ln 3 down. F prime x equals ln 3 times. Now consider it as e to the power something. E to the power jx. So we put the derivative of the power down. So what is the derivative of cosine? Negative sine. So I'll put the negative here in the beginning. Sine, and the angle stays the same. But since the angle has a linear function, the derivative of it is negative 2. So again, I will multiply by negative 2. I have to put parentheses to look like multiplication. Now times the exponential function itself, 3 to the power cosine negative 2x minus 1. So now negative times negative is positive, and we drop the number 2 in the beginning. We don't multiply 2 times 3 because this is ln 3, we cannot say ln 6. You cannot do that. Times sine negative 2x minus 1 times 3 to the power cosine negative 2x minus 1. So that's all about the derivative of exponential functions. It's your turn now. Find the derivative of these functions. E to the power tan 5x minus 1, fx equals 2 to the power 6x minus 1, fx equals root 7, which is a number, to the power 2 cosine 2x minus 1, fx equals 10 to the power cosine x cubed minus 2x squared minus x plus 1. Try to find the derivatives of these functions, and if you have any question, just write in a comment. Thank you for watching.